I should know that whenever I say 4:30, whenever I say a time, I usually mean 15 minutes after that. Like I'm literally never on time. Ever. All right. Today is a pretty quick chapter. If you are new to the world of Kingdomo, I am studying, and I meant to put it on the side. Let me see if I can put it there because I made some banners. Boom! Look, Dominique is on it. As you can see from the little scrolly thing at the bottom, studying for the AWS Solutions Architect exam, which was supposed to conclude. I was supposed to not stop studying, but I was supposed to complete my studying in December. But it was the holidays. I was tired. I didn't feel like stopping, or I didn't feel like rushing through everything. So I've extended it to January. I have the exam scheduled for the end of this month. And to keep myself accountable, I've been doing some lives, going over each chapter of a book that I'm studying. I have the all-in-one guide. I think I can show you here. Hold on. That's going to be difficult. Can I scroll all the way through? Okay, hold on. How can I? I'm sharing my screen. Let me stop sharing my screen real quick, and then I can show you the actual all-in-one study guide. Cool. So let me hide some bookmarks. Share this. Cool. So I'm using this AWS certified all-in-one exam guide. I personally have found it to be pretty helpful, easy to understand, easy concepts. They have labs, walkthrough labs at the end of each chapter, as well as chapter quizzes, which has been helpful to go through. So that's what I've been using, and I put together a slide deck because it's easier for me to share out notes this way. I know before I was taking it in Notion, which is pretty cool. I mean, which is fine for me personally, but I know some people have asked for study notes or to share things. So I thought putting it in a slide deck would be easier. Now, what I have been doing, for example, I showed you chapter 1 really quickly, is that I'll have some key vocabulary, I'll have some high-level concepts, and then kind of breaking down subcategories within each concept. So I've already done chapters 1 through 5, because today we're doing 6. So let me go ahead and get to number 6. So number 6, and let me make this a bit bigger so everyone can see, is about auto-scaling. Auto-scaling chapter was pretty quick, so to speak. The chapter is really about load balancing, some concepts around, let me scroll down, what auto-scaling is. So the definition, of course, is that auto-scaling is a technology that lets you scale your workload up and down based off of a defined set of rules, which is what makes the cloud elastic. So if you are studying for cloud computing and you see something like, what's a benefit of cloud computing? It's elastic. Auto-scaling is what helps they go hand in hand. I'm elastic because auto-scaling is a part of cloud computing, XYZ. Another characteristic of auto-scaling is that, getting your size estimates, if you are someone who wants to be a part of helping an organization transform their environment to the cloud or become ready for cloud migrations and transformations and all of that, digital monetization, getting estimates in the cloud can be pretty hard. Especially if you're a large organization that has thousands of resources, you have a ton of business units, your environment is just complicated. More often than not, either companies overutilize resources or underutilize resources. More than likely, they underutilize. So that winds up being very costly. So auto-scaling kind of helps with that, instead of you trying to figure out, okay, well, I think I might need, 30 instances this month, or I think I might need 50 this month, but in actuality, you need 100, and it would take, a while for you to manually do that. Auto scaling helps out with that process. You can integrate with elastic load balancing, a concept that we will get into in a second. But some benefits of auto scaling: it's dynamic, it doesn't have a limit. It provides a better user experience and performance. You have the ability to perform a health check, which is important in order for you to understand how your instances are running, because what you would not want to do is to have an instance go down unexpectedly, and then boom, you have a service that is out in the middle of Black Friday. Like, you don't want that to happen. Load balancing, like I said, cost control, target tracking, all concepts that we'll get into in a second. How do I scroll down? Cool. So they had some steps outlining how do you create a scaling plan. So one of the first steps that you'll do is to identify your scalable resources. There's a number of different ways you can do that. So you can have a CloudFormation stack. So if you already, CloudFormation is a concept that's within the book that you should be expected to know. So once you have a CloudFormation stack, you're able to go ahead and automatically scan your resources. So what that enables you to do is, instead of you trying to figure out manually what resources within AWS are able to be scalable, this will go ahead and do that for you. You also have the ability to tag things. So there are resources in AWS that are scalable, and there are some that are not, right? So if you tag, as you're creating your architecture, and you tag a resource that you want to scale later, then later on you can go and search for that specific tag, boom. And then lastly, EC2 instances have auto scaling groups that enable them to automatically be scaled up or down, like whenever you want to. Once you identify your scalable resources, then you will specify a strategy. So you have the ability to either optimize your scaling strategy for availability, for example. What that means is if you are prioritizing that you just want your instances or resources to always be available, you would choose that strategy. If you're trying to balance availability and cost, whereas, hey, I want my resources to always be available to my customers, but I also am within a certain budget, right? Like, I can't continue to spend thousands of dollars each month. That would be an option for you to figure out, how do I balance, making sure my customers can access whatever resources, but also that I'm not going over my set budget. And that'll help you in the long run, because then you'll understand, well, hey, on average, we've allocated $1,000 a month, right, to for scaling. Like, if I provision some resources and I realize that it wasn't enough, and I'm going over my $1,000 threshold each month that I've allocated to be a little bit of cushion, and I'm going over that consistently, then maybe that'll let you know, hey, maybe you haven't really provisioned or understood your resources that well if you're constantly going over your threshold, your cost threshold, right? So that option would be really good there. Optimizing for cost is the opposite, of course, of optimizing for availability, where it's prioritizing cost at all times. So if $1,000 is your absolute max, no matter what, if I hit this threshold, then everything needs to shut down. That's kind of what the options would do. This option will do. And then, of course, you have a custom scaling strategy where if you would kind of figure that out, instead of having Amazon, instead of having their algorithm figure it out for you based off of cost or availability, you can just create a custom scaling strategy. With this, though, you would need to know what your environment is. You would need to know, hey, I know I will only use 50 resources a month or some shit like that. What's next? So did I skip what is auto scaling? Scaling plan. I did skip a thing. Oh, I have them backwards. Okay. I was so confused just now because I was like, how do we get to elastic load balancing core components without going over elastic load balancing? Okay. So I'm going to go over this one first. So another concept in the chapter is about elastic load balancing, which comes up very, very often, no matter if you're what cloud service provider you're in. This the concept of load balancing comes up. So a definition is a fully managed service automatically distributes incoming application traffic across multiple applications. You use microservices, containers, XYZ. They'll all be hosted on EC2 instances, and it'll just help you kind of manage that. Some benefits, again, most of the resources within AWS are elastic, which means, again, scalable. Elastic and scalable are two separate things, but one in the same. ELB can integrate with different services. It's secure. It has an integrated certificate management, SSL decryption, port forwarding. You can mitigate DDoS attacks simply because it terminates traffic at the load balancer before it hits your instances, which helps to avoid, like if someone was trying to flood, of course, your instances with traffic, the load balancer would kind of cut that. High availability. So an important note with this is that even if your instances or your applications, I had put a note here, if your applications are not redundant across availability zones, Elastic Load Balancing as a service automatically is. So you can automatically get redundancy by using load balancing, and it's cheaper. There are different types of load balancers. I need to fix that a little bit because it's a little bit too close. You have your network load balancer, which works at layer 4 of the OSI model, which you should definitely be familiar with. It is a connection base and it supports TCP and SSL. You have your application load balancer, which supports layer 7 of the OSI model, supports HTTP and of course HTTPS. What this particular load balancer does is it looks at the header and that's how it decides what action it should take. And by action, it means where should my traffic go, like to which application. And then Classic supports Classic instances. It can support both your network and application layer, which means that it works at both layer 4 and layer 7. But you can only have one load balancer here per application in comparison to the other two. Otherwise, you have to use DNS to like resolve it to everything. So again, Elastic Load Balancing has a whole bunch of components in it. There's a whole chapter this whole chapter was pretty much dedicated to Elastic Load Balancing. So I would definitely think that's a concept that is on the exam that you should be familiar with. So some core components of Elastic Load Balancing, it has some listeners, and listeners are where you define like which protocol and port in which your load balancer is going to listen in for incoming traffic. So an example they had here is like, if I am listening for traffic, if you're using your application one and is listening for traffic, of course, over port 80 or 443, because that's using the HTTPS protocol. And if I also enabled, 10, you can support it. It supports up to 10 listeners, which means it supports up to like 10 ports. So it really just depends on what you have. So an example that they had in the book is, say if you have one load balancer, and then behind the scenes you have a website, one that you have an application that hosts images, and then you have an application that hosts, we'll say media, so to speak, right? Like separate media, we'll just say music or something, or some of the case may be. You would have that maybe on 2 different ports. Your load balancer will understand, hey, if someone is trying to process, an image, they would go to this application. If someone's trying to process media, they would go to this application. If they're trying to process documents and you have that, on another application, the load balancer is essentially telling, where's my traffic going to go? If you're an image, you're going here. If you're media, you're going here. So that's all what load balancers does. By default, a listener does not have any conditions. So whenever you start up a load balancer, it will automatically have a default listener or default rule. That rule doesn't have any conditions set on it. So it does not specify where traffic should go. It has no conditions whatsoever. So you should definitely change that so that way you can specify where your traffic should be going. There's something called path-based routing when it comes to load balancers. And all that is it's routing traffic to respective applications. It can have up to 10 different sets of rules. They differentiate this for some reason because the I guess my reasoning that they would probably differentiate this specifically for load balancers is because of this default rule, right? So if my default rule doesn't have any conditions, all of my traffic is just going to go wherever. It can go to like one, it can go to another, or traffic can go to any one of them. But if I specifically say, no, I want this application to be for images only, without having path-based routing, without having conditions, without having rules, your load balancer essentially is not smart enough to know where that traffic should go, which is why I'm sure they emphasize this within the chapter. There's also something called target groups and targets, which is just a logical grouping of targets behind a load balancer. So I was talking about how you can have two applications, you can have containers, microservices, instances, whatever the case may be. Just know that your target group is essentially whatever your resources are in the back end behind a load balancer. And also it's important to understand that load balancers are a regional resource. So I think I said this a couple of chapters ago. I think I might reiterate it every chapter, but essentially you should understand what resources are what's called zonal, and then what resources are regional, what resources are multi-regional. And that's important to know because as you're architecting your infrastructure, and if you are a multinational corporation and you only create resources within one region or one availability zone, it will be really, it won't be impossible for your customers to access your stuff, but it might be difficult, right? Especially if you're a company who can't afford latency, right? You can't afford to have a lag. You can't afford for your customer experience to be degraded. Then you need to make sure that not only is your resources redundant, but you need to make sure that they're available across multiple availability zones. But you would only know that if your service is regional or multi-regional or not. So elastic load balancing, be sure to know that it is a regional resource. And rules, something that I said above before, but rules just provide the link between listeners and your target groups. It consists of conditions and actions. So essentially, if I'm saying, hey, I'm creating a rule that this traffic over port 80 should go to this application, but traffic over port 443, which is HTTPS, which is a secure protocol, should go to this application XYZ. Something I don't think I put here is to, so with load balancers, as with, I want to say most resources, but with load balancers specifically, because that's what we're talking about, you have the option of making them external or internal, which is very self-explanatory. External means my load balancer is exposed to the public, exposed to the internet, anyone can reach it, versus having it internal, which means only my internal environment can access it. I'm going to put this before I share it out, but I'm going to put it as a note. But you should know, of course, for security best practices, to make sure that you understand what traffic, sorry, I dropped something. You understand, what traffic and security practices you should be checking on with that load balancer if you do have it externally facing. They have that as a note, so I'll be sure to add that later. Dang, was that it? I said it was a quick chapter. I didn't know it was that quick. Okay, cool. We can get to some questions. I never know where to write my questions. So that way you guys can see them. Here, let me see if I can create a note over here. Come here, mouse. So yeah, I aim to have all of this done. So there's only 3 more chapters after this one, which is great because I feel like I've been going through this book for quite some time now. But there's only 3 more chapters after this, and I don't think they're very long chapters anyway, which is also great. So I would like to, in a perfect world, get them done. I would like to do another one this week and then 2 next week so I can have them completed and then take the exam at the end of the month. But, life happens. Life has been busy. I don't know if anyone else has been feeling like it, but as soon as you came back from the holidays, because the holidays were so slow, and now I feel like all of a sudden there's just so much work to do. There's so many deadlines coming up. Everyone wants a piece of something. Okay, let me stop talking so I can concentrate, because I'm like, what am I looking for right now? I'm looking for my study notes certifications. There we go. So that way I can write down solutions architect, study notes, questions and answers. Boom. Let's do, this is chapter 6, right? So chapter 6, Q&A. Let me minimize this. Drag and drop this on over. Cool. And can I present? Ooh, we in business. All right, cool. So question number 1, where do you define, and I'm looking over here because my screen is over here. Where do you define the details of the type of server to be launched when launching the servers using auto-scaling? Do you do it in an auto-scaling group, in your launch configuration, an Elastic Load Balancer, or your application load balancer? So what's asking is, where do you define, so where's the configurations when you're doing your auto-scaling? Now, auto-scaling group is not accurate because I'm trying to recall the definition because I just read it today. So with auto-scaling group, all it is a group of instances that is enabled to auto-scale. That's not necessarily where you would put your configuration. It's just where you put, so if I have like a group here and this is where I'm putting all my instances is, and I'm saying, okay, I know eventually I would like it to auto-scale, that's where I'm gonna put everything. Launch configuration sounds more like it because Elastic Load Balancer is not where you would do that, and neither is your application load balancer. So I'm gonna go with B. Let's see. Number 2, what happens when the Elastic Load Balancing fails the health check? Choose the best answer. And I hate that because on exams, you either have choose 2, choose 3, choose the best answer, choose all that apply. Like, I like it when they at least say choose 2 or 3 because then I'll know, like, I need to choose 2 or 3. But if you say choose the best answer or choose all that apply, the best answer could be 2, right? Or the best answer more than likely probably be 1, because when it says best answer, automatically in my head, I'm thinking you're saying not choose the answer you think it is, choose what the best answer would be, because the CISSP does that. It tricks you. It'll have you thinking, the CISSP and the CISM, the CISM, where they'll have you thinking this is the answer. Like, and from a security professional standpoint, like that would be the answer. But coming from more security manager on the business strategic side, that is always going to be the answer. So that would trick you up. Nothing to do with it here, but I just hate how they trick you when it comes with answers. So anyway, what happens when your ELB fails the health check? Does it fail over to a different load balancer? Does it keep on trying till the instance comes back? Does it cut off traffic, starts a new instance, or does it start a bigger instance? So automatically D is out for me because, and let me make this bigger because I realize you probably can't see. There we go, much better. Cool. D is out for me because why would you start a bigger instance if something is failing? I'm gonna say no to A because what if you don't have another load balancer available? So that's not what your default would do. If I'm not mistaken, it doesn't keep trying. I think it cuts off traffic and starts a new instance. I want to say yes. I hope yes. All right, number 3. When you create an auto-scaling mechanism for a server, which 2 things are mandatory? I like to choose 2 because at least I know how many answers are supposed to be there. So you need 2 answers of when you create an auto-scaling mechanism for a server, what are mandatory? Do you need an ELB? Do you need an auto-scaling group? Do you need DNS resolution? Or do you need a launch configuration? So I'm going to rule out ELB because you don't, load balancing is not a requirement. It's if you want to put one up. I don't remember if auto scaling group is required. I don't believe DNS resolution is required because that was pertaining to classic load balancing. So I'm going to go with B and D simply because A and C doesn't really make sense. At least I hope it doesn't make sense. All right, number 4, you have configured a rule that whenever the CPU utilization of your EC2 goes up, auto scaling is going to start up a new server for you. Which tool is auto scaling using to monitor the CPU utilization? Is it using CloudWatch? Crap, I do not remember reading that. Does it use CloudWatch metrics, output of the top command, ELB health check metric? Oh, duh. It depends on the operating system. Autoscaling uses OS native tool to capture. Okay, that's not it. So I'm going to go with ELB health check because, wait. Sorry, I'm going back. So a trick that I encourage people to use when you're going through testing, either in the real world scenario or practicing. If you have a set of questions and one question doesn't make sense. So what usually happens to me is if I'm answering questions, so for example, I'm answering number 4 and C stood out to me, but if ELB health check metric is what's helping it, which I think it is, would that not be then mandatory within auto scaling in order to auto scale? So that's what, like, I'm thinking too much into it. And then that's when you start deep diving and then you wind up changing your answers. And now I'm confused. So auto scaling, EC2 can automatically auto scale itself without needing an elastic load balancing. So I'm not going to change this answer. But in this question, if my CPU utilization is going up, I'm going to say the health check metric, because health check will let you know like what the state of your resources. I don't feel like it's D. Output of the top command doesn't really make sense to me. And CloudWatch is something that you would attach to it, but I don't think that would necessarily trigger auto scaling. So I'm going to say C. Let's hope. Let's see how that goes. All right, number 5. The listener within a load balancer needs 2 details in order to listen to incoming traffic. What are they? We went over that, so you choose 2. In order to listen, for a listener, I believe it needs a port number and a protocol. I don't believe it needs an address. Operating system isn't necessary. I don't think, IP address is necessary either. So I'm going to say B and C. I hope. Number 6. Which load balancer is not capable of doing the health check? Application, network, classic, none. I don't remember anything saying that it couldn't do a health check. I know application and network definitely does. I wouldn't know why classic wouldn't be able to, other than the fact that I remember saying that you can't have more than 1 application per load balancer for the classic. But not that the classic can't do a health check. So I'm going to say D, none of the above. I'm going through these answers a little too quickly for my liking. I'm hoping that's because I actually read the chapter this time. All right. If you want your request to go to the same instance to get the benefits of caching the content, what technology can help provide that objective? A sticky session, using multiple availability zones, using cross-zone load balancing, or using 1 elastic load balancer per instance. Also, another note, as you're going through not only AWS, but any cloud service provider, any certification, you need to know the abbreviations of the services, right? If you don't know what ELB is, it might be hard for you to answer questions. So you should know that ELB means elastic load balancing, or that EC2 means that they're talking about instances, or whatever other acronyms, abbreviations that we have in this field. You should definitely know that. So if I want if I want my request to get the benefit of caching, not a sticky session, I don't think using one load balancing per instance. Wait, I actually don't know. No, I don't think that makes sense. That doesn't make sense, actually, now that I think about that again. Cross-zone load balancing, I don't remember coming off of that. Maybe using multiple availability zones for redundancy. I'm going to say yes, redundancy for caching. That makes sense in my head. All right, number 8. You are architecting an internal only application. And remember, I said load balancing can be internal or external. So important to know keywords like as you're going through questions. So how can you make sure that your Elastic Load Balancing does not have any internet access? So which means it's not an external, this is internal, it's a private resource, it's not going to the internet. So do you detach the internet gateway from the load balancer? Do you create instances in a private subnet, hook up ELB with that? Your VPC should not have any internet gateway attached, or when you create the ELB from your console, you can define whether it's internal or external. Damn, all these answers are actually pretty good. So just based off of my reading, I do not recall anything about having to attach an internet gateway or that I needed to create a specific VPC or any of that good stuff. What I do remember is that when you create your Elastic Load Balancing from the console, that you do define whether or not it's internal or external. So let's go with that. Again, I'm hoping that your girl is just out here reading because I am flying through this. Which of the following is a true statement? Choose 2. ELB can distribute traffic across multiple regions. It can distribute across multiple availability zones, but not multiple regions. It can distribute across multiple availability zones, or it can distribute across multiple regions, but not multiple availability zones. Shoot. So 1, I said it was a regional resource, right? So if it's regional resource, I automatically know it can, if I know it's a regional resource, then I know it can span across multiple availability zones because multiple availability zones make up a region. So like North America is a region, and within this region, there are, I don't know how many Amazon has, but like there are multiple availability zones, meaning there's a West Coast region, maybe a central region, a mountain region, a southern region, a northern region, a northeast region, like however they divide up availability zones, but all those availability zones put together make up a region. And I know from our notes that we just went over that Elastic Load Balancing is a regional resource, which means C is one of them. So that means A is out, and D is out because we don't know it can go across multiple regions. So I'm going to say B and C. I feel like I had B and C. I did for number 5. Let's see. Number 10. Last question, I think, right? Yep, cool. How many EC2 instances can you have in an auto-scaling group? Shoot. I do not remember. I remember something being unlimited. Was it auto-scaling or was it? I don't think I had that in a note. I did. I said I had something that was unlimited. I'm trying to recall because I had a concept. I had a resource that said it was unlimited. But then I also remember reading something that said, oh, there's a cap on this, but it's not a hard cap. It's a soft cap. All you have to do is contact AWS and they can like increase the limit. But now I can't remember what that was. Was that instances or was that something else? I want to say it was instances. Holy schmoly. All right, we're going to have to guess with this one. Damn, I was doing so good. And then I got to the last question and now I can't remember. Okay, how many instances can you have in an auto-scaling group? I'm tied between D, that there is no limit. There has to be a limit. Well, no, because it says auto-scaling is a elastic resource. The whole point of it is like, if you need 1,000 instances, you got 1,000 instances. But I also feel like that's unreasonable, because then that would cost you a whole bunch of money. Okay, I'm torn between D and C. I feel like I'm going to go with D. When in doubt, always goes with what starts with your name, which is D. Don't do that on the exam, though. All right, cool. Answer time. So 1 is B. We got that right. Good job. You define the type of service to be launched in the launch configuration. Auto-scaling group is used to define scaling policies. ELB, remember we said, doesn't make sense, and all that good stuff. So 2 is C. Got that right. When elastic load balancing fails over, an internal mechanism that is transparent to end users, that it keeps on trying. Wait, what? Elastic load balancing keeps on trying, but if the instance does not come back online, it starts a new instance. Okay, cool. So it does keep on trying, but it does stop. Number 3 is B and D. The launch configuration in auto-scaling group are mandatory, which I thought, because load balancing isn't really mandatory for EC2 instances. Darn. Oh, wait, go back. Auto-scaling relies on CloudWatch. Wah, wah, wah. Okay, we got one wrong. Let me see if I could do this right. Did I highlight it? Yeah, I didn't highlight it in a good color though. So let me move this over a little bit. Let's highlight this in orange. Okay, cool. So number 4 is not, I believe the answer I had put was Cloud Health Check. It was auto-scaling relies on CloudWatch metrics to find the CPU utilization, which makes sense. CPU utilization is a metric. CloudWatch watches metrics. I was just remembering that Health Check. I need to go back and read what Health Check does again. Using Top Command or native OS tools, you should be able to identify CPU utilization, but auto-scaling does not use that. Number 5 is B and C. Listeners define the protocol import on a load balancer of what it listens to. 6 is D. Load balancers are capable of doing a health check. All load balancers are capable of doing a health check. So that means your network, your application, and your classic load balancer. Number 7, oh darn, got that one wrong. Number 7 is not B, it is A. Using multiple availability zones, you can distribute your load across multiple availability zones, but you can't direct the request to go to the same instance. I have to go back to that question. So 7 equals A, and I think we said 4 equals A as well. I'm gonna go back to that question to reread what the question was. Number 9 is D. You cannot attach or detach an internet gateway, because remember I said I don't remember recalling that in the chapter or in the notes that I had written. Even if it has a VPC, and even if you take out the internet gateway, as long as it's external facing, and that's why it's important to define your resources, like define all the configuration of your resources from the beginning, because as this is saying, if you choose this to be an external facing load balancer, but you're like, oh, I don't need that anymore, I'm going to change, I'm going to take out my internet gateway, I'm going to take out the components that require it to be external facing. If it's still external facing, it will still have internet connectivity. So make sure you define it as an internal resource, so that way you don't have those security issues of it being public facing. Number 9 was B and C. Load balancers can span multiple availability zones, but it cannot span multiple regions, because again, it is a regional resource. And then 10, there is no limit. Okay, good, I got that right. See, when in doubt, pick D. There is no limit of instances you can have in a scaling group. However, there might be a limitation in your account that can be increased. Okay, so that's what I read. There might be a limitation in your account that could be increased by logging a support ticket. That's what I thought. Wait, that doesn't make sense. Because if there is no limit, I forgot what they said that the the hard stop as to why it would increase. Because if there's no limit, why would I need to log a support ticket? But whatever, we got it right, which is cool. So let's go back to 7 because I was a little confused. I forgot what that question was. So if you want your request, yes, to go to the same instance to get the benefit of caching the content, we said the answer was A. I don't recall a sticky session in the chapter. Maybe I need to go back. But that's fine. Getting 2 out of 10, not a bad deal. And especially because this one, I was pretty close. I was a little confused. I knew D was out. I know B was out. I was a little confused because it said health check metric, and you can use health check for stuff. I need to define what you use health check for. But now we know what tool does autoscaling use whenever your CPU utilization or any kind of metric, it's always CloudWatch. If you see the word metric, more than likely it's probably going to be CloudWatch. All right, chapter 6. Again, I've already done, let me back out of this a little bit, can I? I've already done, as you can see, there's like 82 pages in here now. And let me make this a little bit bigger for you guys. Come back up. Thank you very much. Cool. I've already done chapters. Chapter 1 was an overview of AWS. Chapter 2 was about storage on AWS. Chapter 3, it was about a virtual private cloud. Chapter 4 was an introduction to EC Elastic Compute Cloud, which was a long chapter. Number 5 was about identity and access management. Number 6 is about auto scaling. If I'm not mistaken, the next couple of chapters is going to get into security best practices. And I think we have 2 other services to cover. Don't quote me, but there are 3 more chapters left in this book. I'm going to add them to this entire slide deck. So that way now there is a full deck of notes, high level notes. These are not in-depth notes. So I highly encourage you to read some book or utilize some resource on top of this as a way to study. For me in particular, because I'm reading the book and I don't want to keep having to read the book all over again, having these high level notes or just having like key vocabulary, for example, can I click on this? Having things like this where it's just like key vocabulary within a chapter. Can I identify of knowing, like, can I define authentication, authorization, and auditing? Like, do I know what roles are, best practices? If I can speak to that, then I'm good. But if you are new to cloud computing, if you're new to AWS, if you're not familiar with resources, security concepts, cloud concepts, then I highly encourage you to utilize something like this and a book or maybe some videos. There's plenty of resources out there for you to use. So it's abundant. Cool. Thanks for tuning in. I will be back next week, hopefully. I say next week because I would really like to do this week, but I'm not 100% sure. And I know every time I say I'm going to do something, I wind up not doing it. So I'm not going to do that to myself. I'm not going to commit. My year this year is I'm not doing commitments that I know I just can't keep. Like, I'm not going to keep saying, yes, I'm going to do this when I know I don't want to. So I'll be back next week for sure. At least I can commit to next week. I commit to one day a week, just so that way we can go over the next couple of chapters. We're almost done. Again, I'm taking the Solutions Architect exam at the end of this month. And then next month, I'm trying to decide if I'm going to do GCP, only because I have a really good surprise in store that makes me want to go over it with everyone, that I'm going to announce soon once it's complete. But I am definitely doing my CISM exam, which is I was about to say Chief Information. Is it Chief? No, it's not. That's why I hate having acronyms, because I can never, it's the Information Security Manager exam. The other one, not the companion. It's really more like I would say it's a next step to CISSP, simply because CISSP is for the professionals and the CISM is for those who are going the manager route, but that's where I'm going. So I'm going to take that exam in Q1. So therefore I'm trying to figure out, do I want to squeeze in another smaller certification before that, or do I want to just put my efforts there. I haven't really decided yet. I'll figure that out. But thanks for tuning in. I'll be back and I'll share this out later. Bye.